Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to another NL Math Man Math Help stream. Um, yeah. Today we're back. We're back after the long weekend. Hope you guys had a nice relaxing time for a Victoria Day holiday. Guten Tag. Yes, wie geht's? Um, yeah, my that's basically the end of my German there, pretty much. Kartoffelschnitzel. I don't know. Kartoffelschnitzel, it wouldn't even make sense, right? That would be a potato. I guess it'd be a fried potato pancake, right? A Kartoffelschnitzel. That'd be okay. I could eat that. It's some light reading. Ah, I think I still have a German textbook here someplace. It was called Wie geht's, which is why I remember that phrase, obviously, because it helps. Um, yeah, before I get into talking about my math for the day, I did some light research, I suppose, the weekend, and I got. Actually, let me hold on a second. Hold on a second. I tried to alter my chroma key a little, and it's not really getting the background well. So let me do that. There we go. That's better. We're doing it live. Doing it on the fly. So behind me, downloaded a bunch of new books. Yes, feels Goodman. Feels good indeed. Here behind me, directly behind my head, we see my backpack. This is a backpack that I've had for quite a few years. It's one of the Ridgeway Kelty ones. Not a resound, not a not that I'm endorsing them, although I should. I really should, because I've had that backpack for a long time, and it's no worse for wear than I had when I first got it. But this shot behind me was from a hike that I talked about previously. And like I said, I did some digging through my old files, and I found more pictures of that one of my hikes around Loch Ness. A sales affiliate, yes, yes, exactly. I'm obviously getting a cut, right? Just use the download link that you find there below to purchase it, so they know that you came from me, right? There isn't actually a link below. I should get on that though. I gotta show hiking on stream occasionally, right? I could stand to have some endorsements. But yeah, this is from the hike through Scotland that I talked about last week, I believe. I think it might have been last Monday. I talked about this one, and I talked about how I found that Newfies of Loch Ness plaque. So I just wanted to go back and wanted to prove to you that I found it, right? So here, right behind me right now, we see sort of a picture from a rest site. If I zoom in over here, this is just a few feet away from that, looking out over, so you can see sort of how steep the hill is, right? And that's Loch Ness there. A few years ago, Lloyd's of London offered a huge cash reward for anyone who's able to prove they'd spotted the Loch Ness monster. Yeah, well, I mean, all you got to, I mean, was the huge cash reward 350, $3.50? Because Loch Ness monster, I hear needs goddamn tree fitty. Loch Ness. It's the Girl Scout with the goddamn Loch Ness monster. All right, this is a G-rated stream. I got to stop the South Park references. It's good day, Esther. Yes, welcome. I don't believe I have any stuff to get to for your courses today, though. I have quite a few things to get to, as we see over on the side here. If you've got something for me to cover, just drop me a line and I'll get to it. 2.4 million US dollars for verified pictures of the Loch Ness monster. Yeah, I mean, but the thing is, a Loch Ness monster is blurry, right? It's not the photographer's fault. There's a large, out of focus monster swimming through the loch, and that to me is all the more frightening. It's a Mitch Hedberg joke, kind of. I mean, his was about Bigfoot, but Loch Ness monster at all, it works. Oh, Cuddy Sark, the whiskey maker. Yes, I've had Cuddy Sark. Yeah, they're prohibition. That one's 50%. That's a savage overproof. It's like 100 proof. It's good stuff. They got Lloyd's to underwrite the contract. Oh, okay. Yeah, yeah. But I just wanted to show one other thing from the Loch Ness hike that I did, right? Because I mentioned this plaque, and here it is. Look at that. Look at that. The Newfies of Loch Ness. This was right there, right? This was the one that down below. I mean, you can't see it. This was the full picture, but the other one that I've got of the plaque is not very um, legible at the distance that it's at. But that was the one commemorating a location where Newfoundlanders went during World War I to cut the Newfoundland Forestry Corps went to go logging to help support the British war effort in World War One, right? And my great grandfather was there, maybe even this exact site. Doesn't Canada have a huge Scottish population? Yeah, yeah, of course. The East Coast, especially Nova Scotia. I mean, Nova Scotia literally means New Scotland. Yeah, exactly. It's literally what I was just going to say. Yeah. Um, Newfoundland, strangely enough, didn't get a ton of Scottish population. It was just from a weird because most of Newfoundlanders descended either from Irish people, Irish or mostly actually West Country English are the ones that came over, and sort of the fishermen from the West Country sort of squeezed out a lot of the other people that were on the island, like the Basque and the Spanish and stuff as well, and eventually became sort of a battle between the English and the French for control of the fishing off of Newfoundland, which wasn't really ended until the end of the Hundred Years' War, or Anyway, I'm not going to go into the history lesson, although I do write up did write up a history intro for one of the English courses about that about the fighting between the English and the French in Newfoundland. So it's an interesting topic. But anyway, yeah, that's the so this forest here that we see in this exact picture. This might have been the exact forest that my great grandfather was logging, circa 1914 or so, because he lied about his age, and when he went over to fight in World War One, he actually didn't go to the front right away, which could be why I'm here today yammering on about hiking and delaying talking about mathematics. Anyway, yeah, history and stuff like that is definitely an interest of mine, and I could ramble about that for ages. But today I do have some responsibilities to get to, believe it or not, and one of those is going to be that A level math. You remember all the math textbooks like C1, C2, etc. Um, I can't remember exactly what the math textbooks were. No, I did GCSE maths. And all the books now like C1. Okay. Yeah, I can't remember exactly what was in those, but yeah, all the topics should be ones that I'm familiar with for sure. Today, I'm going to start off with a bit of an intro to distance teaching, right? So that'll be for some of the new students that I've got starting off. We'll just look down through sort of what you had to do and how you log in and access your textbook. I'll do a little bit of an introduction to set theory, which is the first topic in the first course that one of my new students is doing. Then I'm going to do some basics, fun cross multiplying and unit conversions, which are there's two students that are currently on the exact same spot in Math 1102A. So I'm going to go through a bit of that. So to go over to the distance teaching intro, well, first up, I'm going to go over to my Chrome window here because I'm going to talk about just how we find the textbooks, basically, right? So Kaylee, or is it Callie? I don't know. I'm not sure. Not too bad at set theory, so actually your unofficial TA for today. Yeah, thanks. Thanks, Layer Darth. Glad you're here, having my back. So I'm going to bounce over to this. Kaylee, I hope I'm pronouncing that right, because it was spelled a little different than what I was used to. But this is the page that I linked you to, the Nelson one. Log in with your email address. Well, you'll see the you see the username here that I gave you. Password, mine's going to populate automatically so that I'm not giving it out over the internet. But I've given you the password as well, so you know how to log in. So this is the page. So you just punch it in there and go log in. I mean, right? Like, come on, we've seen internet pages before. We know that what happens there. So down through here now, these are all the books from Nelson that we have access to. Now we do have access to other math books, but you're only going to need one of these. The one you're going to need is this very last one here. You can see me mousing over it there, right there. Principles of Math 12 student ebook. That's the one that you're going to be using. So click on there. It'll come up eventually with a page looking like this, right? So now over here, we're going to click Principles of Mathematics 12, and you're going to get a drop-down menu, which goes into all these different chapters. Now, of course, we are starting in Chapter 1. You're just going to go Chapter 1 Set Theory, click there. Then Chapter Opener, let's see, I've already downloaded a few of these, so I'm going to show you how to download one. I'm going to click on Section 1.4. We're starting with Section 1.1, so this one over here. But like I said, I'm going to show you. I'm going to click on this one because I've downloaded a few of them already. So we just click there and it comes up over here. Click here again, and then we'll see the sort of a preview pop up over here, what you're going to do is you're going to click Open File here like this. And then it's going to open a PDF like so. Now you can either read it off of here, so log back in every time, or what you can do is the same thing I'm going to do, which is go over here to download, click there, and then it's going to open a window. You don't see the window opening because of the way OBS captures this, but just trust me, there's a window opening and I'm navigating to a place and I'm saving it. We see, the downloads thing pop up in Chrome down here, and so on. So that's how we're going to go about accessing the textbook and saving it, right? And this is the same textbook for all three of the ones that you're doing. So all of these chapters out here, these are going to be the ones that are covered in your study guides. Okay. So just basically go to the site that I said, log in, and then Principles of Math 12 is right down the bottom. This blue one with the diamond-shaped arrangement of parachutes. That's the one you'll be going to. Okay. The main thing then I wanted to get on to talking about for your intro is how to read the study guide. So that's back on over here. So first up, this is going to be a little bit dry at the start. Not going well, right? Because math is normally not dry at all, is what I'm saying. Right? Math is normally riveting and entertaining and compelling. But this is going to be a touch dry to start because I'm just going to be talking about our regulations for the program that we do here. Right? So this is going to be So, Kaylee, I know I sent you an email earlier that was rather extensive, quite long, with a lot of detail, and I know it's pretty dense, but it covers pretty much all the bookkeeping and housekeeping stuff that we need to get out of the way for you to do your math program online. Just to break down the main points of it, so distance teaching intro, number one is notes are not required, but are strongly recommended. Don't mind my handwriting. I'm trying to go fast. I explained this in the email to start off as well, but you have the solutions for all your notes at the end of your study guide, or sorry, at the back of your textbook. So the notes ones are from your textbook. Now, during distance teaching, you're not actually going to, like I said, you're not going to be required to hand all those ones in, right? But those ones are, say, if you flick back over to Chrome for a second, down here where it says end matter, right? You'll see end matter, glossary, and answers. These ones are really useful. Glossary is really useful too. But the answers one are all the solutions for all the notes questions that you're asked to do, right? So that's where you're going to find those. Right? Uh, so then assignments follow the units and are required, right? So if you look over here, we can see on the right side of my screen, there's this document over here. So this is your study guide, your first one, right, that I've given out. If we scroll on down, we can see here Unit 1 set theory, right? And these are the notes, questions, required work, pages, this, numbers like that. They're really good to do for practice. And sometimes, say, if you have a question about your assignment, instead of answering that a question about your assignment directly, I might tell you to go back and look at some of the notes questions, or I might answer one of the notes questions for you. Because the thing is, where your assignments are required for marks, I'm not always going to answer all your questions on the assignments. I will answer every question that you ask about the notes. So it's a really good way to get some help from me, right? So down here, we'll see it says ask instructor for review sheet number 1, complete test number 1. Okay, that's after complete assignment 1. So required work, complete assignment 1. Assignment 1 is found on the next few pages. So if I keep scrolling down, see, right? Assignment number 1. So that's what's in here. So you'll just do those, either print them out and do them, or just do it on blank paper like I'm doing here, and just write down like assignment 1, question 1, assignment 1, question 2, alongside the working, so I know what questions those workings correspond to. Then you're going to take pictures of it with your phone, or you can use a scanner or some other sort of method, and then you'll email to me the solutions that you have for those activities. You'll notice that it also mentions Ask Instructor for Review Sheet 1. Right? Review sheets didn't used to be required when we were on site, but now the review sheets are what's taking the place of the notes marks. Right? So after you finish the assignment, you get a review sheet. Then you do the review sheet kind of like another assignment. The review sheet is a really good assignment because it's very similar to the kinds of questions you're going to get on your test. So really important to go down and do those ones. And you'll submit them to me the same way. Just those ones are not included in your guide. I had to give you those. Right? And then this stuff is probably fairly straightforward and self-explanatory, right? Tests follow the review sheets. Like after you do a review sheet, you're then eligible for a test. Now, I gave you quite a detailed testing policy in the other email that I sent. But remember, tests are only Tuesdays and Thursdays, 9 a.m. to 12 p.m. And you have to have your work in at least the previous day, at least by noon on the previous day, normally to give me enough time to correct it. And you have to clearly indicate you want to write your test. All that stuff is included in the email talking about testing policy, right? And then for the academic courses, which are the ones you're doing, there are exams as well. Those exams follow all the unit tests. However, good news is, unlike sort of like, unlike high school, we don't have a final exam at the end. So you're only actually going to have one exam per course, and then that section of the math is done, right? So you're going to have a test, say in this one where there's 3 units, you'll have a test on each unit, then an exam that covers all 3 of those units. Then you're going to move on to 3101B, and A will be a thing of the past in. However, you will see those same topics again. The same topics get dealt with again and again, sort of in more detail. Even though you're only doing 3 courses for yours because you started off on the grade 12 ones, you're still going to see a few topics a few times. Right? I think that covers most of the basics for what you're going to be expected to do for these. And like I said, the emails that I sent were very thorough, as far as I can tell. I think they were very thorough anyway. I don't think I left anything out. But let me know if you've got any questions about those, because there's a lot of bookkeeping there. But anyway, for now, I want to go back over. If we see my intro screen, I did want to talk about Introduction to Set Theory, because that is the first topic that you've got in this course. Right? Let me go back over so we can see my lovely backpack again. Right? So I'm going to go back on over here. We're going to look at a little bit of set theory. So we see Unit 1, just to again sort of go down through how we're going to go to do the study guides. Right? So at the start, it tells you some of the objectives, what you're going to need to know. Right? Then it has some required work. So define the following terms. Those ones you definitely should do the definitions for those, because these are all terms that are going to be really important for our studying. But if we go down to here, required work, read pages 6 to 14 and complete pages 14 to 18. Right? So I've already got it downloaded here, so I'm going to bounce over this. These are the pages in the book that we're talking about. Right? And it's section 1.1, like we got from that online dashboard. Oh, right, it skips a page at a time when I do this, doesn't it? Yeah, look at that. So I'm going to, let's see here. Let's go down through this very first page here and just talk about this a little bit. Okay, so this is going to be 3101A intro. All right, I should also give a little bit of background about how the streams are going to work. So the way the streams work is that I take questions, whenever you send them in, and I usually get to them on stream the next day. And then after the stream is over, I send you a list of the notes that I write, and then links to the video so you can see my past broadcasts, you don't necessarily need to watch live. You can watch the past broadcast, which is a very good feature that Twitch has. Um, if you want to interact live, I would recommend doing that because that lets you message me if you're say while I'm partway through an example if you want me to change something or clarify something. So it can be a lot more like we're in class actually working together, right? Just you're talking to me through text and I'm responding, but I will see the messages that you drop in chat, right? It might be like a 30-second delay or something, but it won't be a lot. Right, so this is just going to be page one, actually. Page one in the textbook? Oh, page six. Page six, don't mind me. Okay, so just a little bit of an intro into set theory. How can Jasmine use sets to characterize Canada's regions? Well, list the elements of the universal set of Canadian provinces and territories. Well, what is a universal set? Basically, a universal set is all the possible elements here, right? So the universal set, C, is of course going to be I'm going to use, let's see, well, Yukon, Northwest Territories, Nunavut, um, BC, Alberta, Saskatchewan, Manitoba, Ontario, Quebec, New Brunswick, Nova Scotia, B, what am I doing here? PEI, and Newfoundland Labrador. Right? There you go. So that's the universal set, and we usually use these sort of curly brackets to denote a set like this, right? This is how we write set notation. So let's see here. One subset of C is the Western provinces and territories W. Write W in set notation. Okay? Sure. So then for B, sometimes I like to alternate colors, although I am running out of my black pen. My good black pens are running out, and gonna have to brave a trip to Dollarama one of these days. Get myself some more pens. Um, so W, the Western provinces. It says provinces, right? So I know Western provinces doesn't include Yukon, Northwest Territories, or Nunavut because those are territories. So I know the Western provinces are going to be BC, Alberta, Saskatchewan, and Manitoba. Those are usually the ones that are included as the Western provinces. So there we go. Right? The Venn diagram to the right represents the universal set C. The circle in the Venn diagram represents a subset W. The complement of W is, what's that? W prime. Sometimes we read that as W prime. In this set, we'll sometimes read it as W naught, right? Which means everything other than what's in W. So describe what W naught contains. Write W naught in set notation. Okay. Well then, I'll say CI. W naught um, all the provinces and territories other than the Western provinces. Right? So it contains everything other than the Western ones, right? Because the Western ones were what was in set W. So W naught is everything else that is required to finish the universal set, basically. We also call it the complement. Complement me with an E, not I. Complement with an I is like saying that someone, that someone's math stream is very engaging and entertaining. That would be a compliment. A complement with an E would be saying, that the list of the rest of the provinces going along with this completes the full list, right? So write W naught in set notation. So W naught is going to be Yukon, Northwest Territories, Nunavut, Ontario, Quebec, uh, New Brunswick, Nova Scotia, Prince Edward Island, and Newfoundland Labrador. There we go. Right? Explain what W naught represents in the Venn diagram. Okay. Well, how about I draw it? How about I draw just it represents a mutually exclusive set, right? It just represents an entirely different set other than the one that's already there. Now, this stuff might seem fairly basic, and it is, right? This is just a very brief intro to how we're gonna start off this unit, right? I don't know, Kaylee, you haven't. I imagine you haven't really looked at the book a ton yet, but whenever you do take a closer look at it and find some questions that you want me to go over, please just let me know, and I will go over them as soon as possible. Let me see. What am I going to use as my stencil today? What am I going to use? What's a good one? There we go. That's kind of cool. This will be a preview for some of the stuff I'm going to talk about other days. We'll see if we can get anyone to figure out what kind of coin this is. And what is a province exactly? It's pretty much a large administrative region, right? Well, yeah, I mean, a province in Canada is, I mean, it's analogous to a state in the U.S. UK doesn't really have regions quite the same as provinces, right? Because of course, Scotland, Wales, and Northern Ireland are constituent countries in England, right? So they're not actually provinces or territories per se. But yeah, a province is a large region, like just like a state would be in the U.S. I'm going to use this coin here. Maybe Albert Einstein, the real Albert Einstein, not the fake one, was able to guess what the last coins were that I showed on stream, right? Which earned him extra marks. I mean, it didn't, but I say it did. Oh, he is here. Oh, great. Well, maybe you can. Maybe. Holy moly! My finger was just like out of joint after that. That was weird. Maybe you can tell me what coin this is. Yeah. Maybe take a screenshot of this one. Icelandic kroner. Icelandic kroner were the last ones. Yeah, this is not an Icelandic kroner though. This one's not. It was before. Oh, it. I'll give you a hint. I'll give you a hint. This one is no longer a legal tender. It's hard to see. It's hard to see with the with the quality of my document cam over here. Let me just zoom in a little bit. There we go. Yeah, you can see it half decent there. There. What is that one? Won't focus good. Yeah, yeah, I know. Yeah, it's having some trouble. Anyway, maybe I'll see if I can take a picture afterwards and put it out as a brain teaser to figure out what kind of coin that is. Although if you could see the type of alphabet that's on there, it would be fairly clear, I think. And here's the back of it. Some dude with looking very stately with a lot of curly locks, right? And that one's not legal tender anymore. There's a hint for you. Anyway, back to this question. So C was going to be the universal set, right? So this one out here is all of the different provinces and territories. In Canada, yeah, we do have two different ones, provinces and territories. Now, if you quiz me on the actual technical differences between the two, I honestly wouldn't be able to tell you. Just the territories are a lot smaller with a lot fewer. Well, they're large, like administratively. There's a lot fewer people there. Yeah, maybe that's a civics lesson for the future. I got to figure out what's the exact technical difference between a province and a territory in Canada. So this would be W here, right? The set W, which would be BC, Alberta, Saskatchewan, and Manitoba. And W not over here is just going to be, it's a mutually exclusive set, right? A mutually exclusive means there's no overlap between the two. And this one over here is going to be all the rest of it. Yukon, is it YK or YN for Yukon? I'm going to put in YN, but I'm none of it. Ontario, Quebec. I do know Quebec is PQ, Province de Quebec, right? And B and S. Oh boy, I'm running out of space. PEI and NL. Right? Gotta go west to east. I always do stuff left to right, right? Because that's how you read. That's how you read. I read left to right. I put on my shoes left to right. I list my provinces left to right. Okay. Anyway, so Kaylee, I think you're finding out now that your teacher is haphazard and flying all over the place, but hey, at least you can pause and rewind the videos and fast forward past my yammering. Um, okay, how's about I scroll on down and we'll see here if we look back over. This was just a part from the notes, right? The initial required work was pages 14 to 18, numbers 2 to 5. So I'm going to do a few of those, and I'm just going to model sort of how we will expect them to be submitted. Right? So let me go down to page 14 to 18 over here in the textbook. Again, right? Some good scrolling noises. Always makes for good radio. Okay, this is good. Yeah. Math 3101A, Unit 1. It's going to be page 14, and I'm going to do question 1 here. Okay. Imelda drew the Venn diagram to the left, so we can see that one. Imelda described the sets as follows. C equals produce, F equals fruit. S is fruit you can eat without peeling. I mean, you can eat a banana or a pineapple without peeling. You just got to really want it. And V is vegetables. Do you agree with her descriptions? Um, C is produce. Well, all of it's produce. Sure. Let's see. F is fruit. Okay, so we're saying peas, corn, carrots, beans, potatoes are not fruit. Well, I guess that makes sense. Um, S is fruit you can eat without peeling. And that's a subset of other fruit. Yeah, sure. Uh, do you agree? I'm going to say yes. Or we could say no, because you can eat an orange. No, because you can eat an orange without peeling it if you really want to. No, that's just silly. No, that's just silly. I'm gonna say yes for categories make sense. Sure. Right? Like I should have said pineapple. You can eat a pineapple without peeling it if you're really into it, you know. But you gotta have a firm roof of your mouth sort of thing, right? Uh, Describe another way Imelda could. Oh, I scrolled off. Could define the sets in her diagram. Um, it's a bit of a weird question. I mean, there's loads of other ways she could do it. She could have, I don't know, fruit with seeds versus fruit without, right? Um, yeah. So S could be fruit with seeds, say. It's just kind of asking for another option that we could use, right? So apples and pears, of course, have seeds. Oranges, pineapples, and bananas don't always have sort of seeds in them, right? Oranges can. I know oranges can have sometimes have seeds and sometimes don't. Um, why does it make sense that what does this symbol mean here? Got any better hints on that coin since it was hard to see? Um, I'll just leave it there. I'll leave it there. It's let's see. Well, I'll say it's from one of the technical definition for a province, a unit of government. That sounds about right. I'll say Albert Einstein. This coin comes from one of the oldest one of the oldest cultures in the world. We'll say one of the oldest, I guess. I'll say the well. If I say, oh God, I don't know. I'm struggling to find a clue that's not going to make it too easy. Right? It is from Europe. Um, one of the oldest democracies in the world. We'll say. Boy, that almost gives it away, though, doesn't it? Whatever. Whatever. Just it does almost give it away though. Hey, uh, now By the looks of Buddy, it's Roman. It's not Roman. No, no. Slayer Darth. Slayer Darth got it. Oh no, no. Then you're not one of my students. You can't even get extra marks. Oh no. That is Greek. It's drachmas, right? So these are not legal tender anymore because Greece uses euros. Yeah, it is Greek, right? And if you could see a bit closer there, you can clearly see sort of the Greek language lettering around it, but it's a bit blurry. I had an amazing trip to Greece. Actually, that was one of the last. I think that was the last trip I took before I left Europe. Maybe I'll show some pictures and banter about that one a bit at the beginning of a stream sometime. We're gonna have to get a better way to show my coins so it doesn't have so much glare, right? Although if we're talking about Roman coins, look at this one. Look at this one. Can we see? Oh, that's just really showing up as a. This one's just kind of showing up as a blur. It's hard to see this one. Ostensibly, this is the oldest thing that I own, right? Although I guess only the stamping of it is older because the metal kind of continues to exist, I guess. The oldest thing that's been in this form. Anyway, it's hard to see as well. Really cool web page. Oh, for basic math symbols. Okay, sure, yeah, yeah. I'll check that one out after. But yeah, we have some math symbols here. So it says that lists a lot of the most common math symbols. Yeah, great. Yeah, that could be a really good resource for the students. Thanks. I'll check that out after I'm done here today. So what does this mean? This looks like SCF. What does that mean? Right? But you'll see these definitions as you're going through here, which means S is a subset of F. Right? And there's a page in your book that I'm not seeing at the top of my head here. But these, if you read down through the notes, it will talk about all the different symbols. Yeah, including for set theory. Well, thanks. Yeah, yeah. Because set theory is a lot of it is interpreting symbols. That's true, right? Um, the notes do a fairly good job of having them, but S is a subset of F. Right? Excuse me, boy. So S is a subset of F. Boy, I'm hiccuping. Because S are types of fruit, whereas F represents all fruit, right? So list the disjoint sets, if there are any. Let me scroll back over. I meant to scroll and not just highlight my text. There we go. So disjoint sets, well, we know that F and V are disjoint, which means nothing overlaps between the two of them. But also, we can also say that S and V are disjoint. I know that seems like that one goes without saying because just previously we've said that S is a subset of F. So obviously, if F is disjoint with V, then its subsets would also have to be disjoint. Disjoint means that there's nothing shared between the two of them, right? And again, this is these definitions are one of the biggest parts of what this unit is about, and you will see those definitions as you're reading down through the notes, right? Um, Remember the symbols corresponding to the union and intersection operators, because for me, union means we're all together regardless. Yeah, right? Yeah. I'm pulling for you because we're all in this together, right? Quote red green in my what I use to sign off sometimes. Yeah, exactly. Yeah, the union of yeah. So S say I'm kind of getting ahead of it, kind of getting ahead of what's shown on here, right? But like if there was I like to read them as say and. So if we had this, I would call this as whereas this one here would be. Sometimes we'll read it like those, right? And I know that's supposed to be they're not necessarily and or, but I do find it as a intuitive way of thinking about it, right? Because these means both of them together, and this means it can be either of those two. But anyway, we'll see that stuff a bit later on. This is sort of an extent what we get into eventually, where we talk about the probability of one or the other as well, right? But anyway, I don't want to derail myself a bit too much here. So is F naught equal to V? Explain. Okay, so this is one way of thinking about it. So yes, F naught represents all the produce that isn't fruit, and C only contains fruit and vegetables. Therefore, F naught equals V. Say, for example, there was another item, right? If, say, mushrooms were there, right? Because mushrooms are produce generally, right? But they're not fruit, they're not vegetables, right? They're fungus. So if you had mushrooms down, that would be an element of C that would be sort of out in the gray area out here, right? So that would be out here somewhere, mushrooms would be, right? And if you had those, then F naught would not be equal to V. Because here now, basically every element of this set is either in set F or in set V. So that means that the ones that aren't in set F are definitely the ones that are in set V, right? So determine NV using NF and NC. Well, what do those symbols mean, right? So NV means the number of elements in set V, right? So what's the number of elements in set V? Well, NV, we can see quite clearly from the Venn diagram, is equal to 5, right? Because that's peas, corn, carrots, beans, potatoes, which are 5 items, right? Determine NV using NF and NC. Well, oops, I guess I didn't. But let me just go through and show how we would do that, right? So N of F, well, we can see from the diagram that N of F is also 5, right? Because it counts the ones that are in S, because S is a subset. So oranges, pineapples, bananas, apples, and pears are the 5 that make up the number of F, or the number of fruits, right? And then the number of produce, we see that that's going to be 10, because that's everything. And C, the number of the universal set, is simply the entire number of elements that we've got in total, which in this case is going to be 10, right? So we know that, say, here's another thing we know. We know that the number of F plus the number of F naught has to equal the number of C, or the number of the universal set, right? And we were also told that, we were also found out from before, that F naught is going to be equal to V. So we know the number of F naught is going to be equal to the number of V. So we could go ahead and find it from that, for F the exact way they were saying here, right? So we would say that number of F we know is 5. The number of F naught is going to be our variable. That's going to equal 10. So of course, number of F naught equals 10 minus 5, or equals 5. Oh, I scrolled off my page a bit. But either way, I think that those should be relatively straightforward to get started with. These are not particularly complicated questions, at least not yet. But Kaylee, I know that you haven't really begun the math, I imagine, because you just got it this morning, right? But this kind of shows you the way that I would want the working written out, right? Make sure to have your page number there if you're writing out your notes, or if it's an assignment. Up here, say, Math 3101A Unit 1, you could say Unit 1, Assignment 1, or something like that, right? And then just write out your working down through here. You can do it on line paper, of course. I'm using unlined paper just for the visuals on the screen. Okay, so yeah, that's just a quick, or it wasn't that quick, it was about 40 minutes long. That was an overview of how to get started then with your math units. Now I'm going to go back over to my intro screen here. So that was the first 2 bits down. Oh, the first 3 bits down. Distance teaching intro done. Accessing online textbooks done. Introduction to set theory also done. Okay, so now I'm going to go over to this cross multiplying one. Now this is for, like I said, Math 1102A, but kind of for all the math that we do. Because cross multiplying is a super fundamental algebra operation that you're going to need to use quite a lot, right? If I go back over here to the document display, you will see that I've brought up part of the guide for Math 1102A. So I will start this off calling it Math 1102A. 1102A Unit 2, right? So down through here now, I'm going to show converting units with cross multiplying. You needn't always use cross multiply to convert units. It's just one way of several. And I do sometimes show other ways to do it, just by canceling out your units, which is also a useful way to do it. But cross multiplying is a really important skill to have. So the basics of cross multiplying is that if you have a over b equals x over y, so if you have 2 fractions that are equal, you can cross multiply. Let's do it all in capitals. To get AY equals BX. Okay? So we call it cross multiplying. It's cross because the pieces move, right? They cross over each other, hence the name. So if we have, say, A over B equals X over Y, this one comes up here like this, right? This one comes up here like this, and they sort of cross over each other to then turn into AY equals BX. Now we can use this in a lot of cases for a lot of different types of algebra, and you'll see it very commonly. I'll mention, the way that we do the working here is just you take your conversion factor and then you take your sort of example one and then you cross multiply them, right? Oh, look, yes, I love it. All right, so finally again, look, I found another pen that is a portable hole in space-time. That's great. That's really good stuff. Okay, that was a visual gag, by the way, if you were just listening and wondered what in the world I was on about. Hey, Alf. Hey, thanks for dropping by. It's very, very cozy here today. Yes. Okay. So what we're gonna do is I'm gonna do a few of these here from example 3. We'll see. Actually, let me zoom in a little bit closer. I'll bring up my other display. I haven't used this one yet today. Zoom on in even a bit more. Right? And you can see here they've already done the examples. They've already found the answers here. But we're going to go ahead and we're going to find them with cross multiplying. Right? I'm not quite sure, but my camera does seem to be a touch blurrier than normal. I'm going to have to get back at that, see what I can do to sharpen her up a little. But here now, for 3A in the notes, what we have is 30 inches equals blank number of centimeters. Well, first what we got to do is we've got to get our conversion factor, right? And the conversion factor that we're given for these ones, and we always use the ones offer sheet. We don't necessarily Google them. That'll give us a little bit of a different answer. You're welcome to Google stuff to look it up afterwards, right? But say on a test, you're not going to be able to. So we generally will practice it using the ones from our textbook or our guide, not necessarily the ones we find online, which might be a little bit different, right? So we're going to do 1 inch equals 2.54 centimeters, right? Now what they do is they just do 30 inches times 2.54 equals 76.2. That's totally fine to do, right? Because what the guide shows, a method we call canceling units. Right? And to do canceling units method, what you're going to do is you're going to do, say, 30 inches times 2.54 centimeters per inch, like that. SI system or go bust? Yeah, absolutely. But here in Canada, A lot of arithmetic revolves around converting back and forth between metric and imperial for some strange reason, right? But here now we've got our conversion factor, which is 2.54 centimeters per inch. We see over here, right? Now those guys can cancel. We have inches on top and inches on bottom. They cancel, and we're going to go ahead and multiply and get 76.2 centimeters, like so, right? But the way that I'm going to do it with cross multiply, let me see, I'll do that one in green, although once this green pen runs out, it's the only green pen I've got. I'm going to do a cross multiply method. Now, the reason I'm using cross multiply is, like I said, it's to prepare you for some of the arithmetic and algebra that you're going to see later on, right? Because it's a very useful method. But what I'm going to do is I'm going to set up, say, my conversion factor. Right? Conversion factor on one side is going to be 1 inch per every 2.54 centimeters, right? You can even read it as that, right? 1 inch per 2.54 centimeters, which conceptually makes a lot of sense, right? We understand that that's sort of what we're saying here. But then we have 30 inches per some unknown number of centimeters. So this is your conversion factor, and this is the on this side is basically what you're evaluating, right? And then, like it says up here, once you cross multiply, this one comes up here, this one comes up here, right? They cross over each other. Same deal down here. This one's going to come up here, this one's going to come up here. So we're going to have 1x on the left side and 30 times 2.54 on the right side, right? And now it's just a sort of a normal algebra question. We're going to have x equals, now break out my good pal over here, right? My mathematical Game Boy. 30 times 2.54, 76.2. I mean, I could have just gotten it from there, right? Like it was written right on my page, but I wanted to bring my calculator to bear on this one. 76.2 centimeters, right? Easy peasy. Same deal if I go over, say, to the another one on the page. I'm not going to walk down through all four of those. Let's just do let's do D, kilometers to miles, because part of the perpetual struggle of converting units in Canada is meters and miles, right? Miles are written MI, meters are written M, right? So when you see 360 kilometers equals blank MI, you got to know that MI means you convert to miles. If it said 360 kilometers equals blank M, well, that's meters. You're just going to times by 1,000, easy peasy, right? But when we're converting from kilometers to miles, we're going to have to use a conversion factor. And in this case, we're going to go 1 mile or 1 mi equals 1.6 km, right? Sometimes you'll see a, was it a 5 to 8 written there, right? Because 5 miles is 8 kilometers. Sometimes that's what you'll see. And you can use that conversion factor with the cross multiply method perfectly fine, right? So if we were to do the canceling units, right? So the canceling units method, like the textbook does, or like the guide does, right? We're going to do, let's see, we have our 360 kilometers, 360 km, and I do like this method. I like this method for these types of questions because it does show another really useful skill, which is doing arithmetic with your units, keeping your units there and then canceling units out, right? So we have, because we know now that our miles are going to have to be on top and our kilometers are going to have to be on bottom. Kilometers had to be on bottom because the kilometers had to cancel, and we have to have the miles left. No reverse Polish notation on the calculator. I'm going to have to look up what that is. Reverse Polish notation. That sounds good. Polish is, well, that's pretty good in general. I could go for some pierogies and kielbasa. That'd be a nice lunch. Cabbage rolls. Parents used to live in Manitoba. I remember they talked about the homemade cabbage rolls and stuff they'd have at some of their friends' houses. Apparently, it was very nice. Anyway, so it's going to be times 1 mile per 1.6 kilometers, right? Now what they did is they divided by 1.6. But how do we know here now that we had to divide by 1.6? Because I said the canceling units method is always multiplication, right? But here now, we know that we have to divide because kilometers have to be on bottom, because the goal in canceling units is to get those guys to go away. So 1 kilometer has to be on top, the other kilometers have to be on bottom, right? So we're going to have, this is going to now become 360 divided by 1.6, which is going to equal 225. And we're going to be left with miles, because miles are the units that are left here on top. But now for this unit, and again, like just in general, I do like to show the cross multiply method. And of course, as you learn with algebra and with sort of these math operations, 6 of one is half dozen of the other, right? They do very similar things. Just I do want to show sort of the different way of doing those, right? So we're going to have conversion factor on one side, of course, right? So it's going to be 1 mile per 1.6 km, right? And that's going to equal some unknown number of miles. Oh, per 360 km, right? All right. And it's essential, like I mentioned over here, same, boy, there we go. Oh, no, we're a little bit slanty, aren't we? We're a little bit slanty. I readjusted the position of my cameras a little bit over the weekend, and it turns out they weren't quite back where I wanted them. So it's the same order of units, right? If we have miles on top on the left, got to be miles on top on the right. Kilometers on the bottom on the left, kilometers on bottom on the right. Has to be, has to be, has to be. Now we're going to go ahead and do our cross multiply, and we're going to get 360. We're going to have 1 times 360 on the left, and we're going to have 1.6 times x on the right. Now what the heck do we do? Right? What in the world? We're not even done yet. How do we, right? 360 is 1.6x. Well, we've got to solve for x, right? This is what we're doing here. And this is one reason why this is such good fundamentals, is because now you're having to just do a normal algebra question and solve for x. Right? So we're going to do 360 divided by 1.6 equals x, or 225 equals x. So 225 miles is 360 kilometers. Right? So that's it's a bit of a glance into how we're going to do those two. Now for let me see here. Go back over to my intro page. I wanted to do unit conversion specifically. I know those were some unit conversions that I was doing just now, but I'm also going to do a few specific ones. Kaylee, if you're still watching, which you know, this is another part of what I do for the math streams, is that whenever there's a good teachable moment, not necessarily because someone got a question wrong, sometimes it is, but whenever I see a good teachable moment in some of the work that I'm correcting, I then take it and go over it on stream. So what I'm going to do here now is a few questions from some work that I corrected this morning that I wanted to talk about, and then after it's over, I send students their grade on the activity, and then these notes that I write and a link to the video, so you can, you know, come on and see it whenever it's convenient for you. Again, right? I do prefer people to watch live if possible, because that way you can give me feedback to let me know if there's a part of the question that you want more attention paid to or something like that. But watching it afterwards is totally acceptable. Right? So I'm going now to this activity, and this is going to be math 1102A unit 2. Like I said, I do have 2 students currently working on this unit, so these examples are some really good examples for people. Number 2 here. Bob is 5 foot. Oh my goodness. Give me a second, please. Okay. Hopefully the hiccups have been abated. Have abated, not have been abated. Boy, you'd think I wasn't an English teacher, right? Like, you know. So Bob is 5 foot 1 inch tall. What is his height to the nearest centimeter? Well, first, we don't have a. The easiest way to do your conversion here is going to be convert it to a number of inches first, right? Because the conversion factor that you're given, if I was just to bring up the conversion chart, which we'll take a look at over here, the Unit 2 conversion chart, right? These are the ones you'll be given on a test. So we see here that we have an inch equals 2.54 centimeters. So this is the one you're going to use. So we're going to switch back over here. So 5 foot 1 inch, well, 5 foot 1 inch, right? That's going to equal 61 inches, right? Because it's 5 times 12 is 60 plus 1, 61, right? So we're just going to do 61 inches. I'm going to go ahead and do the unit canceling method. It's going to be 2.54 cm per inch. One nice thing about this method is I know which order I have to put my conversion factor in because I know that the inches need to be on bottom, right? And that's per 1 inch technically, right? But we don't really need to write in the per 1 because every number has an over 1, right? But then the inches are going to cancel with inches. We're just going to have 61 times 2.54. And that's about 155. I'm just going to call that around 155. So that is going to be option D for that question. Okay. Now, carrying on a little. I wanted to do question 4. Question 4 on the same activity. This one. Bobsled track at the Canada Olympic Park in Calgary is 1475 meters long. And trust me when I say that the rest of that question reads, what is its length to the nearest yard? Okay, so I have 1475 meters, and I'm going to times that by our conversion factor. Conversion factor for yards is going to be what? Let's see, where over here are we going to find it? Ah, here it is. 1 yard equals 0.9 meters. Okay, so how are we gonna do that one? Well, we know that our meters need to be on bottom, right? Our meters needs to be on bottom over here because we got to cancel our meters and get rid of them, right? So if I was to do unit canceling method, and this is where people oftentimes mess up with this kind of question, because our 0.9 can't go on top. If we multiply by 0.9, we're going to get meters squared per yard, which is a unit that doesn't mean anything. It's a totally meaningless unit. But what we have instead is 1 yard per 0.9 meters. Has to be there like so. Because now we know that the meters on top and the meters on bottom cancel, right? So what we end up with is 1475 divided by 0.9, which is going to be, I'm writing it sloppily, I'm going across the page. 1475 divided by 0.9, 1630, about 1639. 1639 yards. Okay? But also to show cross multiply, right? It's important to have multiple methods that you can throw to in order, in case you get stumped, and like you see your conversion factor like this, and you think, my goodness, what in the world do I do? Well, another way you can do it is there's 1475 meters per some unknown number of yards, and that equals the same thing as, same ratio, or the same factor, conversion factor, as 0.9 meters per 1 yard. Because remember, we have to have the same unit on top and the same unit on bottom on both sides. Now we go ahead and cross multiply, and we get 1475 times 1 equals 0.9 times x. And now x has to be by itself whenever we're in an algebra problem, right? These are algebra skills that, the algebra skills in this unit, and it's an issue about math in general, right? The high school math teaching across the board is that often textbooks tend to assume that you learned all your algebra skills previously and they never refresh you on it. Now, I guess you could say it's on the teacher to refresh you, right? And in this, it certainly is. Someone's got to do it. But in a program like this, where you're working at your own pace, you don't necessarily get the opportunity to revise them unless the teacher goes through and actually points it out specifically, right? Hence why I'm sort of belaboring all this kind of stuff. But now I've got to divide by 0.9 to get the x by itself, right? because over here they're multiplied. This is going to be 1475 divided by 0.9 equals x, which is going to be still 1639 equals x, like that. Right? Let's see. There was one other one that I wanted to get to in this activity here. Let's see. I wanted to do question 16. Okay. 16a. Right? So here we have 82 centimeters equals some number of inches. So I can do 82 centimeters times, right, 1 inch per 2.54 cm, right? And I know that I had to be dividing, right? Because here I had to divide so that centimeters cancel with centimeters, right? So I'm going to have 82 divided by 2.54 is going to equal about 32.3. Now, another thing that I like to beat the drum about quite frequently is that you do need to be thinking about the questions that you're doing. Now, that sounds rude, but what I mean is, say you were going through this on autopilot, just trying to get it done as fast as possible, and you went and you converted centimeters into inches, and you ended up with a bigger number of inches than how many centimeters it is. Now, you probably already know, just from normal life experience, that an inch is bigger than a centimeter. So if you end up with a bigger number of inches, you got to think, hold on, I know, with transparent pen too. You got to say, hold on, that doesn't seem right. Maybe I should go back and try doing something a little bit different, right? And it's always good in a math course like this, or any one of them, to be thinking the situation through as best you can, because that will help you get a good handle on if you're answering the questions correctly or not. 60 miles, right? And we're going to use the same conversion factor as before. So that's going to be times 1.6 km per every mile. Now again, here it's important to know, right? This is a one that people get wrong sometimes, and it's just it's really unfortunate because people take it and divide by 1,000. They say, oh, m that means meters, right? But mi, unfortunately, where we have to deal with imperial and metric at the same time, mi means miles, right? So we're going to go ahead and multiply 60 times 1.6. 96 km, right? Because the miles cancel with miles, we're left with an answer in the units that we wanted, which is kilometers. Same thing with C over here. C is going to be, we got 65 yards is some number of meters, right? So 65 yard, right, times, well, what's the conversion factor that we're going to use for that one? I'm going to show you over here again, right? This 1 yard is 0.9 meters, like it says on there. Right? So we need our yards to cancel, which means when we multiply, the yards are going to need to be on bottom. So it's 1 yard and 0.9 meters, right? So this is our conversion factor. Our yards are going to cancel with yards. We have 65 times 0.9, which is going to be 65 minus 6.5, which should be 58.5. Hey, look at that. Still got it, sort of. Oh, not yards. What am I doing? Meters, right? That was the whole point there, was to get that guy to come out in yards. And now one more here, and then I'm going to be going to move on to one other activity that I wanted to get to. And for 16D, 16D is going to be 93 cm equals some number of blank DAM. Now, this one is a bit different. Yes, this one's a bit different because here now we're actually using what we call the metric steps diagram, or more to the point, what we're using is like these obscure metric measurements that you hardly ever hear about. Like, could you even like who could really show me just off the top of their head how big a decameter is? Maybe some people. Obviously, I should be able to, seeing it's I'm the one teaching it. But what we're going to do to get those is we're going to use what we call a metric conversion ladder, which is this, right? Let me zoom that guy over a bit more. So we see on here, this shows how we're going to move from one unit to the next. And on a test or activity or anything for this unit, you're going to be given one of these guys, right? And then what you've got to do is you've got to say DAM, we can see that is up here, right? There we go, right? And then CM is down here. So that's decameters, and this is decimeters, right? So we have to go up how many steps? 1, 2, 3. If we're going up 3 steps, oh, that's the wrong pen. That's the one that's out. I got to start getting rid of my pens. Right. So we're dividing by 1,000. We are dividing by 10, dividing by 10, dividing by 10, but that is not dividing by 30, right? That's dividing by 1,000, which is divided by 10 to the power of 3, right? So we're going to divide by 1,000 to go from centimeters to decameters. So we're going to have our 93. We're going to divide by 1,000. All that is moving the decimal place 3 spots left, stage left. Okay. 1, 2, 3. Put down our new decimal. There we go. That's all there is to it. Right? So that one there was a touch different than the other ones because that was converting metric to metric, as opposed to converting metric to imperial or vice versa. Okay. There was a little bit more on this same topic that I had listed to get to. I know I'm going to be maybe this is going to go a bit long on this one topic. But I do have, like I said, multiple students working on this exact topic right now. So I do want to discuss this review sheet as well now. Oh. Here we go. So let's see, number 4. I wanted to go over number 4 here today. So convert each of the following. Well, those are, yeah, maybe I don't really need to go over number 4 because number 4 is very similar to the ones that I just went over. Renetta, I do believe I put some comments down on yours to see some notes about those ones. Yeah, one of the main things here is knowing that M means meters and MI means miles, right? So yeah, so if I was to go down through number 4 here, let's say I was doing 4B, right? So 4B has us converting centimeters into hectometers. So 976 cm equals some unknown number of HM or hectometers. Now to do this one, we're going to go back over to our conversion ladder, which is this one. We see centimeters here, hectometers up here, right? So it's going 1, 2, 3, 4. Just writing it out in this sort of full form so you can see sort of what I'm talking about. But you're dividing by 10 4 times, which is the same as dividing by a 1 with 4 zeros or dividing by 10,000. That's all we've got to do here now is divide by 10,000. And well, we can do that by hand fairly easily, right? Dividing by 10,000 means you're going to move to the left 4 places, right? Because the number of zeros shows the number of places that we're going to have to move to the left. So we're going to start here and go 1, 2, 3, 4. Put our new decimal here, a 0 here, and a 0 here. So there's the answer for 4B. Right? I'm going to go through a few of these ones fast and furious, but I did want to do a few examples from this page. So 7.75 km equals some blank number of meters, right? So all you've got to do to go from kilometers to meters, right? If we go back over to our conversion ladder, a lot of us know this one already. It's 1, 2, 3 steps down. 3 steps down mean you're multiplying by 1,000. But of course, kilometers, kilo already means 1,000, right? It's right there in the name. So we know how to do this one. We're going to times by 1,000. So this is going to be 7,750 meters. Okay? But it's important here to notice that this one's meters, not miles. If it was miles, miles would be entirely different. But we will get to one of those here now in a second. Um, 0.85 miles equals some number of yards. Well, imperial is foolish, all right? Imperial system is nonsensical, just outdated. Sorry, America, but I think everybody probably realizes that. But here, if we go back over to our conversion chart, we list these on here. 1 mile is equal to 1760 yards, right? So times 1760 yard per 1 mile. And that's just how we're going to get to the answer for this one. I've got too many things open at once to bounce through quickly. So let me just go through and multiply those. 0.85 times 1760 is going to give us 1496. 1496 yard. There we go. And then for E, I'll just do E and then I'll move on to a different question. E is at 32 meters to some number of yards. Now here, they're really getting slippery, right? Because that previous one had MI, meaning miles. This one has M, meaning meters, right? So now we have to make sure that we're using our correct conversion, because we had to go back over here and find one that converts between meters and yards. So that's this guy here. That's going to be times 1 yard per 0.9 meters, right? Back to the review sheet. Meters are going to cancel with meters, and we're going to be left with 32 divided by 0.9 yards, which is going to be actually a bigger number, right? Because if you divide by a number between 0 and 1, you actually get bigger. Equals 35.6. Another place where people occasionally lose marks that were really easy to not lose is just leaving this as 35.5, but it's not, right? Because the first digit you're rounding off is a 5, and if the digit you're rounding off is 5 or greater, we're going to round the previous one up. I know later on in math, if it's exactly 0.5, we don't. We keep it the same, but we're not going to deal with that now. If it's 5 or greater, it goes up. 4 or less goes down, or stays the same. Sorry, never goes down. That'd be weird. It'd be weird if you actually rounded like the number down. Anyway, and then for one more on this one, I wanted to do number 7, the length plus girth of the given figure. Now, girth is an odd term mathematically, but girth girth just means the distance around the end of the figure, right? For a cylinder, girth is circumference, right? And we know that circumference is equal to pi times the diameter, right? We're told that, and that one's on our formula sheet as well. So for this one here, we've got our radius is 3.2. So we're given this one in radius. So we could say circumference is equal to 2 times pi times the radius, right? Because of course doubling the radius is the same as your diameter. So here your circumference is going to be 2 times pi times 3.2, which is going to be 6.4 pi, which is going to be, now I'm going to use, like I said before, I'm not about this 3.14 life. I like to use the actual pi button on my calculator. So I'm going to go ahead and get about 20.1 here, but I am going to round at the end. 20.1 centimeters. Oh, meters. Sorry, not centimeters. Just given those in meters. So it's a rather large figure. And then length plus girth. Well, as we scroll over here, we see we're already given the height, right? So we're given h is equal to 7.8 meters. So g plus h is just going to be 20.1 plus 7.8. So that's going to be 27.9 meters. And that's all there is to those, right? It's fairly straightforward, I think. I am pushing the end of my normally allotted time. However, I did get asked another question from a student just shortly before I began, so I am going to deal with those a little bit as well. So, Betty Ann, I am going to do a few for sine law, excuse me, and cosine law, if you're still around. Even if you're not, oh my goodness. Boy, I don't know why. I don't know why I'm so hiccupy today. Maybe if I change the background, maybe if I give myself a change of surroundings, I'll stop hiccuping so much. There we go. So let's try this one. Hey, there we go. Nice. That's a that's a nice hiccup preventing sunset. Hopefully, let's deal with that one. Less pollen, right? Because I'm zoomed out further. I'm further away from the trees, so maybe this will help. Although you'd think the winter wouldn't have much pollen, right? You'd think that I'd be good for pollen wise here. But hey, let's zoom out a bit and see if my hiccuping stops. Either way, what I'm going to do is I'm just going to do a few quick ones for the questions you asked, Betty Ann, and then I think tomorrow I will probably return to these and do maybe a few more, right? But I would, seeing you asked today, I would like to leave you with a few examples. So I'm going to do this here. This is page 161, and this is going to be question 1. So this is, what course is this? 2101A, Unit 3. So it's going to be page 161, and this is going to be question 1. Okay. Explain how you determine the indicated angle measure or side length in each triangle. Okay, so for these ones, one reason why this is a really good page to use as examples is because this one are like the ones that you're going to see in your tests more often, in that they don't tell us from the start. They don't tell us if we need to use sine law or if we need to use cosine law. Okay, so these are maybe a little bit small for the stream. So explain how you determine the indicated angle measure or side length in each triangle. So here the indicated one is theta up here, or angle A, right? So to get that one, well, what resources do we have available? Well, to use cosine law, right? Oh, this is something I should put over here, right? So to use sine law, we need a pair of known side and known angle opposite that side. Right? So that tells us how we can use our sine law. We need that. Right? I'll use blue. Okay. Generally, sine law is easiest to use, but cosine law is useful in more situations. kind of what I mean is, if we can use sine law, we can probably also use cosine law. Now, that's not always the case, but it's often the case. It is the case here, right? In this question, we could use sine law. However, cosine law rather. However, it's going to be a heck of a lot of work to use cosine law, because to use cosine law, we would have to first find this missing side, then and only then could we go and find that angle. So using cosine law for this question, while possible, is a heck of a lot more work than what we need to do. To solve this question more easily, I'm going to use sine law. Okay? Because we have this known angle and this side, which is opposite that known angle. And that's what we need, like it says over here, in order to use sine law. We need a pair like that. Because sine law is A over sine A equals B over sine B, right? Where A and A, this is the side opposite angle A, this is the side opposite angle B, right? Actually, I'll just bubble around the whole thing there. That's another little aside, right? So this is just what sine law is. So now, armed with this, I can go ahead and solve for theta up here, right? Because I know now that 2.7 over sine 60, that's this pair here. And then now for this other one, I don't know the angle, but I do know the side. So it's going to be 3.1 over sine theta, like that. Theta just being a symbol that we use to mean unknown angle, right? Now I'm going to go across here because I want to leave myself enough room on this page to answer some other questions. Um, Actually, no, I should be fine. It should be fine to go down. So now what I'm going to do is I'm going to cross multiply. Ha! Aha, good callback. You see what I mean? You see what I mean, Twitch chat? You see what I mean when I say that the skills that you're learning in one part or in one course are going to be useful in the other ones? Well, here, right? Or now we're using cross multiply, the same as we saw in the previous stuff we were talking about, right? That previous one was the very first course. It's the very first level 3 math you do, and you're learning cross multiply. And here we are, like most of the way through the academic program, or halfway through, and we're seeing cross multiplying still, and you don't get away from it. You keep doing that. So we're going to cross multiply here. We'll have 2.7 sine theta equals 3.1 sine 60. I'm not going to work those out yet. We're going to end up with sine theta equals 3.1 sine 60 divided by 2.7. I know that seems like a lot of rearranging, but once you get cross multiplying and the algebra skills down, this will all just be second nature, right? We notice how to move pieces around. Cross multiplying brings them both up to the top, and then dividing gets rid of this 2.7 and moves to the other side. So, like I showed you on a previous day, I'm just going to grab my calculator, my mathematical Game Boy. I'm going to do sine 60, right? Now that is one of the ones that you sometimes are encouraged to remember, right? Sine 60, because that one is, what is that, root 3 over 2, I believe? Yeah, there we go. So that's from the unit circle. Sine 60 is root 3 over 2. But either way, for this program, we're not going to be needing to memorize those. So we're just going to go ahead and plug it into our calculator, like, you know. Anyway, you should usually use the calculator if you have the option, because it stops you from getting things wrong. It's just practical, right? It's just really practical to use a calculator, because then you have less of a chance of getting stuff wrong. You don't have to rely on your memory quite as much, right? 9943, I'll do that one to 3 decimal places. And then, so theta is going to be inverse sine of 0.9943. I wanted to write that out here on the page like so, just so we can see. What I'm doing is the inverse sine. So again, right, zoom in here with my blurry old camera. There's going to be second function sine, because it's this one. It's this one right up there in the corner. Second function sine gives us that. Then I'm going to bring up the answer. So if you have a calculator like this, the ANS one down here just brings up the answer for the last question. Hit enter. But 84 degrees. I'm just going to call that 83.9. 83.9 degrees. So there we go. Right? There was a few steps involved, but all, everything beyond sort of arranging this is stuff that you've seen in previous courses. And even the inverse sine is not that hard. I mean, it's just sort of a reverse lookup kind of thing. And the calculator takes care of the heavy lifting there for you. Excuse me. Really gassy and hiccupy today. I don't know what's going on. Let's carry over here now. Do this one in black so we can see at a glance that there are different workings. Let's do let's do C actually. I'm gonna skip B. Gonna actually no, I'll do all three of these. I'll do all three of these. Why not? Why not? Let's do B and then C afterwards. B is going to be a little bit shorter. For B here now, we have A, B, and C. This angle is 47 degrees. This one is 90. Right? That's what that you got to know that symbol. That's important. Right? And this is side C. So we are looking for side C over here. Right? It's annoying that we use A, B, and C because the lowercase c, of course, just looks like a smaller capital C. We should use like, I don't know, D, E, and F, or D, E, and G even, something so that the lowercase is clearly different. But anyway, I'm going to go with what the book had. So, can we use sine law here? Well, we have, all right, this is 1.8 cm down here. Can we use sine law? Well, we have this side, this angle, and we're looking for this side over here. We have this side, and we don't have that angle. We have this angle, and we don't have that side. What are we going to do? Well, here now, of course, the easy part, or the part we have to notice first, is that it's impossible to know two angles in a triangle. You either know one or you know three, right? Because, of course, a triangle makes 180 in total. So this angle up here, right? That angle is going to be 180 minus 47 and minus 90, which is going to be 90 minus 47, which is going to be 43 degrees. So we know this one up here has to be 43, right? Now that we know that, we do have a pair of side and angle, right? So we can go ahead and write out our A over sine A equals B over sine B, right? So in this case now we're going to have 1.8 over sine of 43 equals, and now we're going to pick these ones over here, right? Lowercase c over sine of 47. I'm not just going to do my full cross multiply because that kind of gets us to steps that we didn't really need to do the full thing over here, but I did want to show you, all the different steps in cross multiply. What we could do is just multiply both sides by sine 47 is really what we're doing, and we end up with our 1.8 sine 47 divided by sine 43 equals c, like so. Now break out the calculator. Sine 47 is that much, times it by 1.8 gives you that much. Then we're going to divide it by sine of 43, like so. There we go. 1.93. Right? Easy. Okay, so I'm going to do that last one there as well. I'm going to try to cram this guy in the corner down here. We'll see how we go with that. And then Betty Ann, if you're watching, you can let me know if there's any other ones you would want me to cover. But yeah, I think this will probably be enough for today for these ones, and then tomorrow maybe I'll have some prepped for before the stream starts so I can get to those. So for this triangle over here, we have 3.0 there, 2.9 here, 2.0 here, and then an unknown angle, theta, right? And now we look over here to see which one we can use. Well, to use sine law, we need a pair of known side and a known angle opposite that side. All three of our sides are known, but 0 of our angles are known. So we can't. We can't use that. We had to use cosine law. Oh, you're here. Oh, great. Yeah, let me know if there's other questions that you want me to go over. But yeah, I think these will be a decent quick recap of how you do these ones. So if you flip back in our book, right, it's on page 160 over here. We see this is the form of cosine law, right? So the final form, for whatever reason, this was the one that I was always taught, was always c squared equals a squared plus b squared minus 2ab cos c, right? And like we mentioned the previous time that we looked at these ones, the most important part about those is making sure that C, the side C, is the side that is opposite the angle you're trying to find, right? So I'm going to put this in a different color. Side C has to be the side opposite angle C, right? So here, because the angle that we're looking for is this top one that's opposite the 2.0, we know that the 2.0 needs to be the one that's over here, right? Now, for whatever reason, your textbook didn't show you sort of the sort of the rearranged one to solve for cosine C, right? But if we move them all around, what we will get is cosine of C is going to equal a squared plus b squared minus c squared divided by 2ab, right? This is what we would get if we rearrange these ones. Now, I showed you the other day sort of how we do that one. I'm only not doing it here just because I'm, running low on space and time. Boy, it's a real sci-fi sort of problem. Hey, running low on space and time. But anyway, I'm going to finish off this question here in the space that I've got probably. So cosine of theta, this unknown one, is going to be 3.0 squared plus 2.9 squared minus 2.0 squared, right? Because remember, the C has to be the one that's opposite the side that we're looking for. And it's going to be divided by 2 times 3.0 times 2.9. So then cos theta is going to equal, I'm going to bring over my calculator here, 3.0 squared is of course 9, plus 2.9 squared, it's going to be 17.1, minus 2.0 squared. I'm going to type it in like a faithful, math teacher here, but I mean, we know that's 4. So it's going to be 13.41. 13.41. That's going to be divided by 2 times 3.0 times 2.9. 17.4. Right? So then I can go ahead and do this. So we know that theta is going to equal the inverse cosine of those two. So that's 13.41 divided by 17.4. Wouldn't always even necessarily write that out. We could just leave it like it was. But I'm going to write down that 0.7707. So then theta is going to equal the inverse cosine of the answer, about 39.6 degrees. Boy, just barely crammed that one in there, didn't I? But there we go. So that is that's a decent example of how we're going to go about doing sine law and cosine law questions, right? And sort of how we're going to be able to tell when we use one versus when we use the other. Right? Just give me a nice full page view here with every millimeter of the edge. And there we go. So I'll send you those notes momentarily once I'm done yammering and go, chug some water and take a lozenge. Anyway, yeah. Thanks for being with me here today. Stream starts soon. Oh, I left that up there. No, it doesn't. Stream has been going for a while. Thanks for being here and hanging out. Hope you found my little intro interesting, right? We're going to move back and we're going to get a bit closer to the edge. Now look out over the lock And over here we get the Newfies of Loch Ness, right? It said I'd bring a call back to that one, right? That was fun. Anyway, yeah, hope the long weekend was safe and enjoyable for everybody. Hope you're rapturously entertained and compelled by my math streams. I'm sure exactly nobody is. Enjoy your evening. Yes, thank you. Yes, you too. If you have a great rest of your day, and yeah, stay safe. Hope to see you all again tomorrow for another wonderful math stream.